Hello everyone, this is Rithick Prabhakar. I volunteered for the program Vidhai, and today we are going to see linear equations. So let's see the contents of this video or the chapter. First, we are going to see the introduction, what are linear equations and things like that. Then we'll see linear equations in one variable and its examples. Then we'll see linear equations in two variables and its examples. Then we are going to see how to form linear equations from word problems and solve them. And then we'll see few problems. Okay, so let's start. What are linear equations? Linear equations are equations with variables of power not more than one. Yeah, so if we have any power more than one, it won't be a linear equation. Any variable, it must have power of 1. So here you can see x is equals to 5 is a linear equation. If you see the second one, you can see we have x into x, which becomes x square. X square has power of 2. But what is the definition of linear equation? The power must be 1. So this is not a linear equation. Then if we see the next one, we have ax plus by is 25. A and b are strictly constants. If they're not constants, it's not a linear equation. As you can see, if a is also variable, x is also variable, the whole thing becomes a power of 2. It's a not linear equation then. So therefore, if you generalize everything, we can write any form of linear equation becomes ax plus by plus cz and so on is equals to p, where a, b, c and p are all other constants and x, y, z and the rest of the terms are variables. So now let's see linear equations with one variable. These are the most basic form of linear equation since it has only one variable. Usually assume x. It's not exactly generalized, but it's very easy to do this because most of the problems they'll consider x. The generalized form can be written as ax plus b equals c. As you can see, there are no more variables. It The first definition of linear equation is power is 1. So the variable we are having here, its power is 1. And the next one is with one variable. There are no more variables because a, b and c are constants. So the only variable here is x. Here a, b, c are constants, x is variable. These forms are easily solvable by manipulating the constants. As I said, a, b, c are constants. By just manipulating them, you can find the value of x. So as you can see here, I'm subtracting b on both sides. Got ax is equals c minus b. Then divide a on both sides. We get x is equals c minus b by a. Here we found x easily by manipulating the constant terms. Now let's see some examples on the next slide. So the question here is find x from 5x plus 15 is equals to 3x plus 20. So let's see if this fits the definition of linear equation with one variable. We can see it's a linear equation because the variable here is only x and its power is not more than 1. It's exactly 1, so it's a linear equation. And if it's a one variable, yeah, it's one variable because x is the only variable here. You can see 5x plus 15 equals to 3x plus 20. Now I'm going to bring all the like terms on one side, meaning I'm bringing the variable terms on left hand side and the constant terms on right hand side. You can see here 5x minus 3x is equals to 20 minus 15, and then 2x is equals to 5, x is equals to 2.5. I just did it by manipulating the terms. It doesn't involve much of calculation. Now we'll see linear equation with two variables. A linear equation is which has only two variables is called linear equation with two variables. Yes, that's the definition. It must have exactly two variables. General form is ax plus by is equals to c, where a, b, c are constants and x and y are the variables. Here you can see a, b, c are the constants and x and y are variables. X and y they form two variables. So it's a linear equation with two variables. Now how to solve them? To solve any linear equation with two variables, we require two linear equations. This is because of the fact that every variable has to be represented independent of the other variable. It means that here we are considering x and y are independent variables. They both are independent. They do not depend upon each other. So they must have two equations which doesn't have the term y. For example, we can have some to solve them. We must have two equations. It's because that here we must as I said, we need to represent them independently. To represent them independently, we must have ax is equals to something and y is equals to something. That requires minimum of two equations to solve them. So if I'm going to generalize the above statement, we can say if we have n variables, we need n equations to solve them, as every single one of them can be represented independently. Yeah, this applies to linear equations. If we have n variables, I need n equations, minimum of n equations. If I don't have n equations, if I have less than n equations, I can't solve for all the variables of n. So let's see how to solve two variable linear equations. Yeah, as I said in the previous slide, the necessary condition is we must have minimum of two equations to solve. Then the first step we are going to do is we are going to choose a variable. Like I said, usually we represent them as x and y. So I choose either x or y. Then multiply some integer to make the coefficients equal on both equations. It means that, so for suppose I choose x, I must multiply the whole equation some integer to make the coefficients on both equations as equal. So since the coefficients are equal, now if I just subtract them, I'll just remove the x, the variable. Here I chose x, so I'll remove x and I'll have only y, and we can easily find the variable y. Here I'm taking as y by simple manipulation, as I showed in the first previous slides. You can simply find the value of y, here y, by manipulating the terms. Then if I substitute this value y, here I'm taking y, so if I substitute this value y in the some either the equation 1 or 2, I'm going to get the value of x. Now let's see an example to understand the previous slide. So I need to, the question is to solve x and y from 2x plus 3y is equals to 8 and 3x plus 2y is equals to 7. So the number one equation is 2x plus 3y is 8 and second one is 3x plus 2y is 7. The step one is choose a variable. I'm going to choose the variable x. Now multiply some integer to make the x coefficients in both equations same. So here I have 2 and here I have 3. I'm going to multiply equation 1 with 3 and multiply equation 2 with 2. Note that if you are unable to find the integer, it's just a simple step. We are just going to find the LCM of both. Find the LCM of the coefficients. The coefficients here are 2 and 3. So what is the LCM? 2 and 3 both are prime numbers, so just multiply them, we'll get 6. And divide the coefficient and divide the LCM by the coefficient to get the smallest integer to multiply. So here I got LCM as 6, here LCM is 6. So for 1, if I'm going to divide 6 by 2, I'm going to get 3. So I'm going to multiply this equation with 3 and this equation with 2. Remember that this is not the only now integers you can multiply. This is the smallest integer. Remember the point, this is the smallest integer to multiply. You can obviously multiply any terms. Now we are going to see an example to solve x and y. To understand the previous slide even more clear with an example. So the question here is I need to solve x and y from 2x plus 3y is equals to 8 and 3x plus 2y is equals to 7. So what was the step one? Step one is we must choose a variable. So what variable am I choosing here? I'm choosing x. Now I'm going to multiply some integer to make x coefficients same in both equation. I'm going to multiply equation 1 with 3 and equation 2 with 2. Remember, if you are unable to get the integer, there's a simple, it's not even a trick, it's just a simple thing to do. Just find the LCM of the coefficients. 2 and 3 both are prime numbers, LCM is 6. So I'm going to divide the LCM with the coefficient to get the smallest integer to multiply. LCM is 6, so if I divide it with 2, I'm going to get 3. So I'm going to multiply this with 3, and if I'm going to divide 6 with 3, I'm going to get 2. So multiply equation 2 with 2. Remember, this is not the only integer we can multiply. Here I said it's smallest integer. You can obviously make both terms as 18. Multiply equation 1 with 9, multiply equation 2 with 6, both becomes 18. There are infinite possible numbers to multiply, but the smallest number can be easily found by LCM. So I'm going to multiply equation 1 with 3 and equation 2 with 2. Equation 1 with 3, it becomes 6x plus 9y is equals to 24. Then equation 2 with 2, it becomes 6x plus 4y is 14. As you can see, the variables x, Their coefficients are 6. Both are equal. If I'm going to subtract them, it become both are going to get cancelled. Then I'm going to have 9y plus 4y. So if I'm going to subtract these both, I'm going to 9 minus 4. It's 5y. 24 minus 14 is 10. So we are having a linear equation with a single variable. So divide both sides by 5, we are going to get y is equals to 2. Now I got y is equals to 2. I can either substitute y is equals to 2 in this equation or this equation. I'm going to substitute in number 1. So 2x plus 3 into 2 is 8. 2x plus 6 is 8. So x becomes 1. It's the 2x. This is also a simple equation with a single variable. So therefore we got x is equals to 1, y equals to 2. So that's how we are going to solve the questions. Now, how to form linear equations and how to solve them. We just saw how to solve them back, so we're going to see how to form the linear equation. How do you know when to use linear equation to solve a problem? Every problem will have plenty of hints to look for. Here are some. So the number one hint is there are usually two quantities as involved. For example, the number of adults and children. Usually both belong to the same class. So we are going to consider same variable. Or the number of coins and notes. Number two is there's a value associated with the quantities. For example, the value of notes and coins or the ticket cost for adults and children. They're going to vary. Ticket cost for adults will be different. Ticket cost for children will be different. Such problems usually involve linear equation with two variables. Typically, one will represent the quantities and another will represent the value associated with it. Usually, like I said, the number of adults and children can be represented by x, and value can be represented by y. Now we are going to see an example. We are going to see the steps that will help to solve them. First, we need to understand the problem. Understand what is given and what is asked. Usual, Usually they are going to ask us to find the value of the variables, but we need to understand what are the variables, where are the variables that we need to understand. Try to familiarize the situation. Second one is convert the situation in equations. They don't just give out the equations. Okay, solve x and y for these. They'll give a word problem, and you need to form the equations from the word problem. So make the unknowns as variable. Whatever they are going to ask us to find, they are the unknowns. So make them as variables and be clear with what the variable represents. Don't get confused with what is this and what is that. So just keep a clear cut idea on what you're going to do. Then you can solve the equations. Like I showed in the previous slide, how to solve them, you can use them to solve. Okay, let's see an example now. The cost of admission to a popular music concert is $160 for 12 children and 3 adults. And the admission was $122 for 8 children and 3 adults in another music concert. So what is the admission for each child and adult? So okay, what was the step one? The understanding the problem. So if you can see the question, you can see hints as $162 for 12 children and 3 adults. So what are the unknowns here? What are they asking us to find? What is the admission cost for child and adult? So that is the unknown. So now what are the hints given? They gave $162 for 12 children and 3 adults and $122 for 8 children and 3 adults. Okay, now if you're going to convert this into equations, so let's take, so I'm going to assume the cost for children, the admission cost for children is X and the cost for adults is Y, because that's what we are going to find. That is the unknown, so that becomes a variable for us. So for the first one, they gave 12 children. So 12 children, each children admission cost is X. So for 12 children, it becomes 12X. And for 3 adults, they said including 3 adults and 3 adults means so 3y. So the 12x plus 3y becomes 162. Similarly for this statement, 8 children, each children admission cost is X. So it becomes 8x. Each cost for each adult is Y. So it's become 3y. 8x plus 3y is 122. Now we have two equations. What is this next step? We are going to make the coefficients of C equal. Here, since we can see already that the coefficients of y are equal, you can see 3 and 3 both are equal, so I don't have to multiply anything with anything. If I directly subtract them, I'm going to cancel out y. So write the equations and subtract them. 12x minus 8x is 4x, 162 minus 120 is 40. So x is 10. X is 10. What is x? X is the admission for each child. Here we consider admission cost for each children. So x is 10 means each children's admission cost is $10. Now how to find the each admission cost for adults? Just substitute the value of x in any of the equation. I'm going to substitute this equation in equation number 1, which was 12x plus 3y is 162. So put x is equals to 10. We're going to get x is equals to 14. Therefore, the cost of admission for each children is $10 and adult is $14. See, it was so simple, right? Now we are going to see a problem. If you want to solve the problem here, pause the video right here and solve them, because I'm going to discuss how to do this in next slide. Okay, so pause right now. Okay, so you can see the problem is a person was asked to state his age in years. His reply was take my age three times, hence multiply the three and then subtract three times my age 3 years ago and you'll get how old I am. What is the age of the person? So what is unknown here? The only unknown here is what is the age of the person. So I'm going to consider age of the person as X. So what are the statements given? Meaning what are the hints given for us? Number one hint was take my age 3 years hence, then multiply with the 3 and then subtract 3 times my age 3 years ago. And then you'll get how old I am. These are the hints given. Take my age 3 times hence. You must follow the order properly. Whatever order was given, that's what you must follow. If you manipulate them, you won't get the right answer. So take it step by step. Take my age 3 times years hence. Hence means 3 years more than the current age, which is x plus 3. Then he said multiply it by 3. So 3 into x plus 3. Then subtract 3 times my age 3 years ago. Current age is x. 3 years ago is x minus 3. Subtract 3 times. So 3 times into x minus 3. So this is the final equation we are getting. And the person said the final expression is his age. You can see that from here and you will find how old I am. So it's is equals to x, because what is x? X is the age of the person. So put the value of x. Now you can solve this as this is a single variable equation. You can try solving them. I'm not going to discuss it here. It's going to be good practice. So the answer is 18 years. If you solve them, you'll get them. So here we'll see another problem. If you want to solve the problem here, pause the video here, because I'm going to discuss how to solve this in next slide. So we have Tanya's grandfather was 8 years older to us 16 years ago. He would be 3 times of her age 8 years from now. And 8 years ago, what was the ratio of Tanya's age to that of a grandfather? Okay, this is an interesting problem we can see. Okay, so here there are two different persons. What are the unknowns asked? What is the ratio of Tanya's age to her grandfather? So we need to find what is her age. We need to find what is her grandfather's age. Meaning we have two variables, two unknowns. One is Tanya's age and her grandfather's age. So make Tanya's age as X and her grandfather be Y. So what are the hints given in the question? Number one hint is Tanya's grandfather was 8 times older to us 16 years ago. So the whole timeline is set 16 years ago from the current ages are X and Y. What is 16 years ago? X minus 16 and Y minus 16. Given Tanya's grandfather was 8 times older. What was Tanya's grandfather age 16 years older, X, Y minus 16? And they said he is 8 times older to her. So 8 into X minus 16. X minus 16 because they clearly said 16 years ago. So the whole timeline is at 16 years ago. Both are at X minus 16 and Y minus 16. So Y minus 16 is 8 into X minus 16. Now he would be 3 times of our age 8 years from now. 8 years from now, what does it mean? Timeline is set 8 years from now, meaning both are 8 years greater than current age. Meaning x plus 8, if you put it mathematically, we'll get x plus 8 and y plus 8. He would be 3 times of her. So y plus 8 is grandfather and 3 into x plus 8. X plus 8 is Tanya. So y plus 8 is 3 into x plus 8. Now we are having two equations with two variables. So what was the condition? You must have, for n variables, you must have n equations, minimum of n equations. We are having two variables, we are having two equations. So if we solve them, we are going to get the answer. You can solve them. I'm not going to solve it here. It's going to be good practice if you do it. So we'll get, if we solve them, we'll get x is 128 by 5 and y is 464 by 5. So what was the question asked? What was the ratio of Tanya's age to her grandfather? So we're going to just divide them both. We'll get 11 is to 53. This is the answer, 11 is to 53. Okay, thank you for watching the video. I hope you understood the everything whatever I taught here. Please check the description for extra questions, lecture note for each chapter. Like the video, share the video and subscribe.